I'm going to show you how to conduct t-tests for paired samples using Excel 365. But first, I want to also review how to do a confidence interval for the mean difference of paired samples. So we are looking at dependent data. So we're going to look at confidence intervals for paired samples or dependent data using the descriptive statistics data analysis tool. And then we will also conduct a hypothesis test concerning the mean difference. And I will again use values from that tool, but I could also show you how you would do it if you did not have the tool. So let's begin. So here, what we have are list prices and selling prices of homes in Dutchess County, New York. Not a very large data set, but good enough for our purposes. Notice list price and selling price, I have actually put before and after because when we're looking at dependent data, oops, too many, dependent data, which is the same thing as matched pairs, you can usually think of it as, it's usually given as a type of before-after data. That's one of the easiest ways to recognize you have dependent data or matched pairs is because it can be considered before and after data. With data like this, we are going to find the differences in order to use the summary statistics tool to get a confidence interval. Then I will also show you how you would use the differences to do a hypothesis test. Then I will show you how to use a built-in data analysis tool to conduct the hypothesis test. So the differences are the before minus after differences. So I'm going to click on the first before price minus the first after price, A2 minus B2. Notice a positive 14,000. Copy this formula down. And what is obvious here is that almost all the values are large positive values, with only exceptions are these two small negative values. So it sure looks like the differences are positive and that the list price is larger than the selling price. We would say the population mean list price is greater than the population mean selling price. Since we are looking at differences, we're going to construct a confidence interval for the mean difference. So we need to find the summary statistics for the differences. So let's go to data analysis, which is always on the far right, and I'm going to do my descriptive statistics on the differences. So let's highlight the differences. Notice I highlighted my label, so that is checked. I want both summary statistics and I want the margin of error, which is given to us by checking confidence level for mean box. We're doing a 95% confidence interval. This value is also the default. Let us click, oh, I need to say where I want my output to go. I don't want it to override anything, so I will put it over here in J1. Click OK. And here is our output. So here's the output for the differences. The sample mean difference is 7250, and the margin of error for the mean difference, the margin of error for, I should say, the distribution of sample differences, okay, this is for the distribution of sample differences, is the margin of error here, 4694.28. Now, if you did not have this tool, you could still do this by using built-in tools in Excel. So to find the mean, you would use the average function. So equals average, highlight the data, and whether you highlight the label or not doesn't matter because Excel will ignore the label. And there is the average, right? The sample mean. If you needed to find the, let's see, the margin of error here. Oh, I didn't show how to do that last time on a different video. For the standard error, what you need to do is take the standard deviation and divide it by the square root of the sample size to get the standard error. So for this, you would need to go, let's see, I'll go down here to standard deviation because you would need stdev.s. So equals stdev.s data, close parenthesis, enter. There's the standard deviation. So to get the standard error, we would do the standard deviation divided by the square root of the sample size, which is very small, it's only 8 pairs. And there's the 1985.21 that we see here. And the reason you need that is if you were going to find the margin of error without this tool, then you were going to have to compute, for the margin of error, you're going to need to compute a t-score times the standard error. So what we would need now is a t-score. So to get a t-score, we're going to use t inverse 2t. The probability is the collective amount in the tails. So since our level of confidence is 95%, 100% minus 95% is what's left in the tails, or the significance. You can think of it as a significance level for the high confidence interval. So it's the 5% that's left over, degrees of freedom, 1 less than the sample size, so that would be 7 here. So that gives us a t-score of 2.3646. Notice larger than 2. This is more than 2 standard errors from the mean. So now to find the margin of error, this 4694.28, we would do the t-score times the standard error to get that 4694.28. So you could do this without the summary statistics, but it's much faster with the summary statistics. Since I have those summary statistics, I can use them to find the left endpoint and the right endpoint of the confidence interval. The left endpoint is the sample mean difference minus the margin of error. I see. So that is 255.71. Then the right endpoint is the sample mean difference plus the margin of error. So plus the margin of error, as you see here, scoot it over, there it is, enter. We want to round these to only 1 decimal place more than the original data. Now, original data actually has no decimal places, so you would think, oh, go to 1. But if we think more in terms of significant figures, we see this really has at most the 4 significant figures because it's really only being rounded to the nearest 100. So we'll just go ahead and round these down to whole numbers and not worry about it too much. Although I guess technically we would want to call this, since it goes only to the nearest 100, this would be 2600, and this would be 11,900. 100, but I'm not going to get that particular. So our sentence, we are 95% confident that the population mean difference between the list and selling prices is between $2,556 and $11,944. Okay, although technically you could just say 2,600, 11,900. But here is the sentence. That's the easiest one to do. Okay, so this here, the differences are positive, right? If the difference were 0, that would mean these were equal. If this interval contained 0, that means the before and after, or the list and selling prices, could be equal. However, there is no 0 contained in this interval. Everything is positive, so this suggests or supports that the difference is indeed positive, so that the list price is indeed greater than the selling price. Or I should say the mean list price, population mean list price greater than the population mean selling price for when this data was given in this location. Let's now go ahead and do a hypothesis test claiming that the list price is greater than the mean selling price. So my differences are a list minus selling, so the claim is that the mean difference is greater than 0. The difference is positive. The null hypothesis, which is always equality, is that the mean difference equals 0, and then the alternative hypothesis is always inequality, so it will be the same as the claim that the mean difference is greater than 0. Since we're working with the greater than, this will be a right-tailed test. Since I do one-tailed tests, like to choose a one-tailed alpha, so instead of 0.05, I like to use 0.025. Let's make sure that is a decimal point. Okay, so now once we have this information, all we need next is Tstat. And the T statistic is a T-score, and it's computed by finding the difference between the sample mean and the value in the null hypothesis. Our sample mean difference is 7250. The assumed value is 0, so I can do minus 0. Notice, since that doesn't do anything, you could actually ignore the subtract 0 and just do the sample mean difference divided by the standard error, 1985.21. And here we have 3.65. Wow, notice that is like an outlier, right? That is more than 3 standard errors from the mean. So that should give us a very small p-value, which then would have us reject the null hypothesis, support the alternative, which is our claim, and consistent with the results of the confidence interval. So for this p-value, we're using a Tstat, so we use a T-dist. It is right-tailed, so we want T.dist RT. Our input is our Tstat. Degrees of freedom, 1 less than the sample size or the number of pairs, so that would be 7. And there we have 0.004. Notice that is definitely smaller than alpha, so we reject the null hypothesis and support the alternative hypothesis. The alternative hypothesis is the claim, so the sample data support the claim that the population mean difference between the list and selling prices is positive, which is the same thing as the population mean list price is greater than the population mean selling price for that time span the data was collected and in that locality. Since we're saying that the mean was different from 0, right? It was positive. We have the differences between the list and selling prices are statistically significant. Or I should say the mean difference between the list and selling prices is statistically significant. Or the mean differences between, we'll do it this way, the mean differences between list and selling prices are statistically significant. So this is a hypothesis test for matched pairs. We used our summary statistics output, so we did use a data analysis tool, but we could even do this hypothesis test or have Excel do the whole hypothesis test for us other than our setup here, right? This is our setup, but we could have Excel compute these values for us. So let me show you how we do that. To do that, we are going to go to Data, Data Analysis, scroll down to T-Tests, and we're going to choose T-Test Paired to Sample for Means. So notice we want paired samples. So, okay. Variable 1 range. So when you do this test, you actually don't need the differences. You can just enter the actual data. So variable 1, list price. Variable 2, selling price. Hypothesized mean difference is 0. I have labels, and I want to have, I'm using an alpha 0.025. My output range, I will put below my previous test. No, actually, I'll put it on the side here. Let's just put it right here in I-21. Okay, and here's what we get. So here is our t-test paired to sample for means. Notice they give us sample means and variances for both samples. So we have our sample means and our sample variances for both samples. We're given our degrees of freedom. And here we see our t-score and the p-value. So there's your t-stat, and right here is the p-value. And again, we see p-value less than alpha, so same conclusion. Now, why did we have to enter, though, an alpha to do the test? That is so the test could generate, Excel could generate what we call a critical value, t-critical. And this here is the score that separates the top 2.5%. Notice that was our alpha, 2.5%, 0.025 from the rest. Okay, that's the value that separates the top 2.5% from the rest. So any t-stat greater than t-crit will give you a small p-value. If your t-stat is greater than t-crit, that gives you the same conclusion as your p-value being less than alpha. But this isn't used as much, but you still see it now and then in the literature, and it is in the textbooks. So this is even the faster way to do your t-test using Excel. T-test pair 2 sample for means. You just need to remember to give your setup and your conclusion. What this test is giving you are the computations. I hope that was helpful, and thank you for watching.